Roughly 1 in 4 students taking this A-level paper in October-November 2023 couldn't answer this question fully. Can you? Now, this question alone is worth 10 marks, so 13% of the entire paper. What that means is, if you were already struggling with the paper up to this point, this is like the nail in the coffin. The threat here is primarily sub-question C, because not only is this worth 5 marks, the most out of the whole question, it's also the most difficult, according to the examiner, as you can see now. And obviously, to do question C, you need the other sub-questions. Let's attack each one by one. Firstly, for A, all we have to do is scan across the cuboid, and we can see that we have 3 units in the I direction, 2 in the J direction, and 1 in the K direction, as we half the 2. And so therefore we have 3I plus 2J plus 1K. That's 1 mark sorted for us. Next, for B, it tells us that the position vector of P is equal to 1I plus 1J plus 2K, and that we need to calculate angle PAM. So basically, P lies somewhere in the middle of the cuboid and connects to A and M somehow, and we need to find the angle at the A part of that, as A lies in between P and M. In other words, we need to find the angle between AM and AP. Remember that the way we find the angle between 2 lines is by using this formula. As you can see, we need both the scalar product and the magnitude of 2 vectors. And so therefore, in this context, these vectors will have to be AM and AP. Working that out, we can see that AM is equal to 0, 2, 1, and AP is equal to -2, 1, and 2. Meanwhile, the magnitude of AM is equal to √5, and the magnitude of AP is equal to 3. Therefore, putting this all together, as you can see the calculations on the screen now, we get theta is equal to 53.4 degrees. Now, this is the most important section, representing 50% of the question as a whole, yet the majority of people got this wrong. Will you be one of them? The hurdle we're facing here is that we can't even visualize it. And if we can't visualize the question, we can't solve the question. So, there's 3 steps here. 1, visualize. 2, deduce the equation. And 3, solve. Number 1, visualize. Firstly, quote, line passing through O and M, end quote, implies there is a line connecting both O and M. So let's draw that line. Next, we're told there's a perpendicular line passing through the line from P. So let's draw that with an intersection of Q. Now it could be you could label it anything, but I'm going to call it Q. So then, based off the question, we're looking to find this bit right here, this length. Deduce the equation. So to deduce an equation here, we know OQ lying on the line OM must be some kind of multiple of the position vector M, which equals 3, 2, 1. So we can let OQ equal lambda times 3, 2, 1 because it's a multiple. Next, we want to find PQ because by finding PQ, we can plug it into the scalar product identity, which tells us that the scalar product of two perpendicular lines is equal to 0. Since PQ would equal -1 plus 3 lambda, -1 plus 2 lambda, and -2 plus lambda, we can multiply that by 3i, 2j, and 1k to get 0. Okay, which ultimately gives us lambda equaling a half, as you can see from the working out. Number 3, solve. So this is the easiest bit, because all we have to do now is just plug in lambda equals a half, because that's going to give us the exact position of PQ, which will allow us to find the magnitude. And doing this gives 0.5, 0.5, and -1.5. Okay, and so after plugging this into the magnitude equation, we're going to get 1.58. So as you can see, this question was actually quite simple if you break it down into parts. And ultimately, we were able to get 10 out of 10, simply through breaking it into chunks and solving systematically.